In the past, revolutions were marked by the clash of swords, the rise and fall of empires, and the rewriting of history through power and conquest. But today, the most powerful revolution doesn't roar. It hums. It pulses through invisible networks. It lives inside microscopic code. And it reshapes the world not through destruction, but through discovery. Welcome to the modern scientific revolution, a revolution not of kings, but of knowledge. The term scientific revolution once referred to a specific moment in history, a time when thinkers began to challenge ancient beliefs and reshape our understanding of the universe. But today, we are living through something even bigger. Not a single revolution, but a continuous explosion of discovery. From artificial intelligence to genetic engineering to quantum computing, science is no longer just explaining the world, it is rebuilding it. Unlike the past, where breakthroughs took centuries, modern science evolves in years, sometimes even months. Knowledge doubles faster than ever before. Technologies become obsolete almost overnight, and the line between science fiction and reality is disappearing. At the heart of this revolution lies one powerful force: information. The digital age transformed data into the most valuable resource on Earth. Computers, once the size of rooms, now fit in our pockets, and with them, we carry access to nearly all human knowledge. But the real transformation isn't just access, it's intelligence. Artificial intelligence is no longer a concept of the future. It is here. It learns, it adapts, it predicts. From recommending what you watch, to diagnosing diseases, to driving cars, machines are beginning to think. And with each passing day, they think better. Artificial intelligence is not just a tool, it is a turning point. For the first time in history, humans are creating systems that can improve themselves. This changes everything. Doctors now use AI to detect diseases earlier than ever before. Scientists use it to simulate complex experiments in seconds. Engineers design entire systems with the help of algorithms. But with this power comes questions. If machines can learn, can they decide? If they can decide, can they replace us? Or will they become our greatest partners? The answer is still unfolding. While machines are learning to think, humans are learning to rewrite life itself. Welcome to the age of biotechnology. Scientists can now edit genes, modify DNA, and even design organisms. Diseases once thought incurable are now being treated at their source. Cancer therapies are becoming more targeted. Genetic disorders are being corrected before birth. And personalized medicine is becoming reality. But this power raises profound ethical questions. If we can change our biology, should we? Where do we draw the line between healing and enhancement? And who decides? For centuries, humans looked at the stars with wonder. Today, we reach for them. Private companies and governments alike are racing to explore space. Reusable rockets, Mars missions, and the search for life beyond Earth. What once seemed impossible is now inevitable. The question is no longer if we will explore space, but how far we will go, and what we will become when Earth is no longer our only home. Every revolution carries risk, and the modern scientific revolution is no different. Technology can empower, but it can also control. Data can connect us, but it can also expose us. Scientific advancements can heal, but they can also harm. From cyber threats to ethical dilemmas to environmental consequences, we are walking a fine line between progress and responsibility. We stand at the edge of a new era, an era where science shapes not just our world, but our future as a species. The choices we make today will define tomorrow. Will we use science to unite humanity or divide it? Will we control technology or be controlled by it? This is only the beginning, because the revolution has just begun. The revolution didn't stop with discovery. It evolved. From understanding the world to reshaping it. From observing nature to redesigning its rules. In part 1, we witnessed the spark. But now, we enter the phase where science does something extraordinary. It begins to rewrite reality itself. For decades, computers have followed a simple rule. A bit is either a 0 or a 1. Every image, every video, every calculation built on that binary foundation. But what if a bit could be both? Welcome to quantum computing, a world where the rules of classical physics no longer apply. Here, particles can exist in multiple states at once. They can be connected across vast distances in ways we are only beginning to understand. This is called superposition and entanglement. And together, they unlock a level of computational power that was once unimaginable. Problems that would take today's most powerful supercomputers thousands of years to solve could be solved in minutes. From discovering new medicines to optimizing global systems to breaking encryption, quantum computing doesn't just improve technology, it redefines what is possible. But with such power comes uncertainty, because when we unlock the deepest secrets of the universe, we must also face the consequences of understanding them. Not all revolutions are about expansion. Some are about survival. Our planet is changing. Rising temperatures, melting ice caps, extreme weather events. These are not distant warnings. They are happening now. But science is not standing still. Climate science is evolving faster than ever, giving us the tools to understand, predict, and respond. Satellites monitor Earth in real time. AI models forecast climate patterns with increasing accuracy. Renewable energy technologies are transforming how we power our world. Solar, wind, hydrogen. The shift has begun. But sustainability is more than technology. It is a choice. A global commitment to balance progress with preservation, to innovate without destroying. Because the future of science depends on the future of Earth. And the clock is ticking. Imagine a world where the smallest things hold the greatest power. Welcome to nanotechnology, a field where scientists manipulate matter at the scale of atoms and molecules. At this level, materials behave differently, stronger, lighter, more reactive. And with this control, we can build things never before possible. Nanobots that travel through the bloodstream targeting diseases at their source. Materials that repair themselves. Surfaces that repel water, bacteria, even damage. Energy systems that are more efficient than ever before. It is precision at the ultimate level. But as we engineer the invisible, we must ask, what happens when we can no longer see the impact of what we create? Because the smaller the technology, the harder it is to control. For most of history, humans built tools. Now, tools are becoming part of us. Human-machine integration is no longer science fiction. It is happening now. Prosthetic limbs that respond to thought, brain-computer interfaces that allow direct communication with machines, augmented reality systems that enhance perception. The boundary between human and machine is fading. This isn't just about restoring ability, it's about enhancing it, improving memory, expanding intelligence, extending human potential. But with this transformation comes a profound question. If we enhance ourselves beyond our natural limits, what does it mean to be human? Every revolution changes how we live. This one is changing how we work. Automation is replacing repetitive tasks. AI is handling complex decision-making. Machines are learning skills once thought uniquely human. Jobs are disappearing, but new ones are emerging. Careers that didn't exist a decade ago are now shaping the global economy. Remote work has redefined offices. Digital platforms have created new opportunities. Creativity, adaptability, and learning are becoming the most valuable skills. The future of work is not about competing with machines, it's about collaborating with them. Those who adapt will thrive. Those who resist may be left behind. We are no longer just observers of progress. We are participants, shaping a world where reality itself is being rewritten. From the quantum realm to the global climate to the integration of human and machine, this revolution is deeper, more powerful, and more personal than any before it. And yet, the most important question still remains. Not what we can do, but what we should do. Because the future is not just being discovered, it is being decided.
We have explored the rise of intelligence, the power of technology, and the rewriting of reality itself. But now we arrive at the most important question of all. Not what science can do, but what it means for us. Because this revolution is no longer about machines, it's about humanity. For thousands of years, humanity has adapted to the world. Now, the world is adapting to us. We have reshaped landscapes, altered ecosystems, and connected every corner of the planet. But the future of humanity is not just about survival, it is about evolution. Not through natural selection, but through choice. A future where disease is no longer inevitable, where lifespans are extended, where intelligence is amplified. But also a future filled with uncertainty. Will technology unite us as a global civilization or deepen the divides that already exist? Will access to innovation be universal or limited to a few? Because the future is not a single path, it is a crossroads, and humanity is choosing its direction. With great power comes the need for great responsibility. Science moves fast, but ethics must keep up. Every breakthrough brings new questions. Who controls artificial intelligence? Who owns genetic information? Who decides how far enhancement should go? Ethical frameworks are the invisible structures that guide progress. They define limits, they establish responsibility, they protect what it means to be human. But ethics are not universal. They are shaped by culture, by belief, by perspective. What one society embraces, another may reject. And in a world driven by rapid innovation, these differences matter. Because without ethical direction, progress can become dangerous, and without accountability, power can be misused. The challenge of our time is not just to innovate, but to do so wisely. What if being human was only the beginning? Transhumanism is the idea that humanity can evolve beyond its natural limits, through technology, through enhancement, through integration. It envisions a future where the body can be upgraded, the mind can be expanded, and consciousness itself may transcend biology. Imagine a world where memory can be stored externally, where intelligence can be increased instantly, where aging is slowed or even reversed. But with this vision comes a fundamental question. If we change everything about ourselves, are we still human? Or do we become something new? a new form of existence, a new definition of life. The line between human and machine, natural and artificial, begins to disappear. And in that moment, we are no longer just evolving, we are transforming. The future is uncertain, but patterns tell a story. By 2050 and beyond, the world may look very different. Artificial intelligence could surpass human-level reasoning in many domains. Healthcare may become predictive rather than reactive. Diseases detected before symptoms appear. Energy systems could become fully sustainable. Cities smarter. Transportation autonomous. Humans may live and work across physical and digital worlds simultaneously. Education could be instant, personalized, continuous. And space may no longer be the final frontier, but a new home. Yet not all predictions are technological. Some are human. Greater connection or greater isolation. More equality or deeper divides. Because the future is shaped not only by innovation, but by intention. Every revolution in history has changed the world, but this one is changing us. We are no longer limited by the tools we create. We are becoming the creators of ourselves. The future is not written in stars. It is written in choices, in the decisions we make today. Will we use science to elevate humanity or to divide it? Will we protect what makes us human or redefine it entirely? This is not just a story of technology. It is a story of identity, of responsibility, of possibility. Because in the end, the greatest discovery of this revolution is not artificial intelligence or quantum power or genetic mastery. It is this, that the future of humanity is in our hands. The revolution is not coming, it is here, and we are becoming the future.